When solving a system of equations, it's a really good practice to make sure that you always start with a system that has the same shape. What I mean by that is it's really useful to set up your system so that all of the x's, all of the y's, and all of the constants are lined up in both equations. In this particular problem, I don't have that because when you look at the first equation, I have a variable x on the left-hand side. Also, there's a variable of x on the right-hand side. I'm going to have a constant when I distribute the 2 on the left. I've got a constant on the right, and then my y's are on the wrong side. I want that guy to be on the left. So the first equation is kind of a mess, and the first thing I'd really like to do is just simplify that equation. So to simplify this, I'll start by distributing the 2 to remove the parentheses. I'll have 2 times x is 2x, 2 times negative 1 is negative 2. This is equal to 4y minus 1 minus x. And I want to get all of my x's on the left-hand side. To do that, I need to move this guy to the left-hand side. I'll add x to both sides to give 3x. 4y also needs to come to the left. I'll need to subtract 4y from both sides. And then this constant term should go to the right. I can move that to the right by adding 2 to both sides. Negative 1 plus 2 is equal to 1. So that's my first equation written in standard form. My second equation, just copy this down, is 4x plus 3y is equal to 1. And now that I have standard form, I can look at this system and make a decision about the best way to solve the system. I'd like to try and do substitution if I can, but because all of the coefficients are not equal to 1 or negative 1, solving for a variable may give me some fractions that I don't want to deal with. Because of that, this problem is going to be a lot easier, for me at least, to use the addition method. The way the addition method works is I need to get coefficients that are opposites on either the x's or the y's. And looking at this system, one of the things that I like is that my y's already have a positive and a negative coefficient, but the values are not yet opposites. 4 and 3 both go into 12, so I can turn those 2 y's into negative 12y and positive 12y if I multiply each of the equations by the right number. The first equation, I've got a negative 4y. If I multiply that by 3, I'll get negative 12. So I need to do 3 times the first equation to get the right coefficient. 3 times 3x is 9x. On the right-hand side, 3 times 1 is 3. To get this positive 3y into a 12y, I need to take the second equation and multiply that by 4. 4 times 4x is 16x. Right-hand side, 4 times 1 is equal to 4. Now that those coefficients are opposites, I can eliminate one of the variables. I can eliminate the y's. The way that I like to do that is always to just keep the first equation. I'll copy it down so I don't lose something. That's a really good habit to have when you start working with systems of 3 equations or 4 equations. And from here in the second equation, I need to add the first and the second equation. Negative 12 plus 12 will be equal to 0. That variable will be eliminated. 9x plus 16x is 25x. Negative 12 plus 12 is 0. That goes away. And 3 plus 4 is 7. Finally, I can solve the second equation. 25x is equal to 7. For x, dividing both sides by 25, I'll get 7/25. So I know the value of x, and I need to figure out the value of y. One of the ways I can do this, and this is normally how I would do it, is to take the value of x and plug it back into one of my original equations. There's nothing wrong with that, but if I do that in this problem, I'm going to have fractions all over the place, and I might make a mistake. So I don't want to go down that path. A better method for me, at least, is going to be to start with that system again, 3x minus 4y is equal to 1, and 4x plus 3y is equal to 1. And instead of doing what we did last time, making the coefficients on y into opposites to eliminate them and eventually solve for x, I'm going to make the coefficients on my x's into opposites, and then I can solve for y. So with that in mind, again, 3 and 4 both go into 12. My first equation needs to be multiplied by 4. That will give me 12x minus 16y is 4. And to get a negative 12x in the second equation must be multiplied by negative 3. So negative 3 times positive 3 is going to give me a negative 9y. 1 times negative 3 is negative 3 on the right. Again, keep the first equation. Don't touch it, just copy it down. And then to eliminate my x's, I need to add the first and the second equation. Equation 1 plus equation 2. 12x minus 12x is 0. Negative 16y minus 9y is negative 25y. 4 minus 3 is 1. And then when I solve that equation for y, I'll have y is negative 1/25. Now I know the value of x and the value of y together. I just need to make sure that I write this as an ordered pair. X is 7/25 and y is negative 1/25.